In this video, we are going to discuss number 22 in the statistics 1 to 2, math 1 to 2, statistics 1, unit 6, assignment 6. So number 22. It says the speeds with which buses pass under the Foncole Cliff are normally distributed with a mean of 85.2 kilometers per hour. So the mean is 85.2. A traffic officer determined that 2.5% of the buses with speed more than 90 kilometers. Okay, so there are 2.5% of the buses with speed more than 90 kilometers. Calculate the value of sigma, the standard deviation. Okay, so clearly thinking of the normal distribution curve and the mean will be in the center, 85.2. 90 is more than 85, so 90 will be on the right side of 85. And we have to look to see in which direction we've got a shade. We've got a shade towards the right because of the word more than. So therefore now, this is a right tail because the probability value is less than 0.5, 0.025 to be exact. Plus we shading towards the right, and already 90 is on the right. So this is a right tail, and we have to find the value of sigma. So basically, we must use the standardization formula. That's where sigma is. Z is equal to x minus mu over sigma. Mu is 85, x is 90. 90 minus 85 will give us a positive number. And we can go into the table to get Z, but we can't go into the table with a tail. We can't go into the table with a probability value of less than 0.5. Because as you can see, this table that we are using is calibrated for phi of positive values of Z, big chunks. So in order to get towards Z, we must subtract 0.025 from 1. So let's go to unit 6 to see if we can get an example similar to this. Then we have to find sigma. We have example 5.8. It's not quite similar because the probability value is 0.7. That's a big chunk. Okay, and 24 is less than 35. So as you can see, 24 will be on the left side of 35.5. And when you subtract 24 by 35.5, you're going to get a negative value. Z will be a negative value, negative 11 over sigma. Okay. But not in the case in our example. In our example, 90 is more than 85. Okay, let's see what example 5.9 looks like. Here you have 18.4%. So that's a tail, 0.184. And above is a right. And where is that? Where is the mean? The mean is 13.2. And you have 16. So 5.9 is an example like our own for number 22. Because 16 is more than 14.2. That puts 16 to the right of 14.2. Plus you are shading towards the right above. So you have a right tail. And here's the value of that tail, 0.184. So clearly 1 minus 0.184 will allow us to go into the table to get the Z, so we can calculate sigma. So as you can see, how it is laid out. By now we are familiar with this working out. Right, so as you can see, it's a right tail. 16 and 13.2. And when you standardize, 0 in the middle, and you have a positive 2.8. Now you must subtract 0.184 from 1 to get the z. Okay, here's the algorithm. P of x more than 16 is equal to P of z more than 2.8 over sigma. 1 minus, and this is will be 1 minus because of the tail, you must have 1 minus phi of 2.8. And here we've got continue with the algorithm. Point 184 was subtracted from 1, okay, and into the table 0.816 to get the z value, okay, 0.816, 0.8159, approximately 0.816 will give us 0.9 for our z. Here it is. Right here it is 0.9. And then you do your algebra and solve for sigma. Sigma will be 3.1 in that case. So therefore, example 5.9, you can pattern your solution on example 5.9. But the in general approach, summarized approach, the 0.184 must be subtracted from 1. You go into the table, you get the z, and you substitute it into the formula x minus mu over sigma. You have x, you have mu. Now you have z, you can solve for sigma. Okay, so all of this working is just formality. All right, so this should help us answer 22. Here we are going to solve number 23 or discuss, better said, number 23 of the Statistics 1, Math 1 to 2, Unit 6, Assignment C. Number 23. It says X approximates a normal distribution with a mean of 63. The mean is given, a variance of 8 squared. So that means the standard deviation is given, and a probability value of 0.410, 0.401. That's the probability that X is less than a certain value of X. Find the value of X. So it's the value of X that is missing. We have the mu, we have the sigma, we have the probability value. So we find the value of X. Now, clearly, we don't know what X is, but we know that the probability that X is less than a certain value is 0.4, 0.1401. 0.1401 is a tail, and this arrow is pointing towards the left. So this is a left tail. Okay. Now, from previous questions, we know that when we have to find either X, mu, mid X, mu, or sigma, we have found sigma and mu already. X is the same strategy. All three variables in the formula, X, mu, and sigma, is the same strategy. You are provided with a probability value. If that probability value is less than 0.5, you have to subtract it from 1 to get the z, put it into the formula for z, and you solve for X. For formality, you can draw your curve, shade the appropriate region, okay, and so forth. Let's look at Unit 6 for an example like this. Calculating X, you can find this starting from page 20 in Unit 6. You can take a look at example 5.1. Let's see if it's a big chunk. It's not a left tail. Let's see if there's another example that is a left tail or right tail. Just a minute. Here it is. Let's see what tail is it. It's a right tail. And then you have the exercises. So we can take a look at the right tail. You can clearly see the probability value 0.1611. All this is formality. All this algorithm is for formality. The curve is important. Okay, you can put the curve and you can see where Z was attempted to standardize, but you're missing X, so you cannot continue. However, you can use the probability value 0.161 subtracted from one eventually, here it is, and use that 0.8389 to go into the table to get the Z value, which is 0.99. Okay, here it is. You go look for 0.8389, 0.8389, here it is. So is it 0? The Z will be 0.99 for probability value of 0.8389. And then you use that Z value, substitute it into the formula for Z, X minus mu over sigma, and then you do some algebra and you solve for X. As you can see, in this case, X is greater than the mean. Okay. So, and it happens to be 94.95. But in our example now, we've got a left tail. So apparently, X is less than 63. So the Z that we get from the table, we have to put a negative sign to that Z before we calculate X. We're supposed to get a value less than 63. So please be reminded, as soon as you get your Z from the table for number 23, you've got to put a minus sign by it, because if we knew the value of X and to fully calculate Z, we would have gotten a negative number. Now this table does not give negative Z's. It only gives positive Z. That's what it is calibrated for. Okay. So you must attach the negative sign to Z before you can solve for X. So please try to include your curve, and you can do the algorithm. If you do not, I will not really penalize you, because the main thing now is to find Z. Here is showing you why you need to subtract, 0.1611 from 1 to get. But for another table that is calibrated with tails, you could have used the 0.1611 directly to get Z. Okay, you can look up other standard normal tables that are calibrated for tails, and you can see you could have gone inside of this, because you'd have gotten, there would all the poverty values would be less than 0.5, and you would have gotten 0.611 there, and you will see that it would be the same as 0.99. Okay, and then you solve for X. So I hope this helps us with question number 22.